Hello, today we are going to start looking at 3.2, solving systems algebraically. We've already reviewed how to solve by graphing, and now we're going to review the substitution and elimination method. You did learn both these methods in Algebra 1. In a couple days, we're going to take these and elevate them to a new level, so you've really got to be able to do them with two variables. So let's review substitution, which is a three-step process. Step 1 is to solve for the easiest variable. We've got a coefficient of 2, 2, 1, negative 4. You're going to choose the one that has a positive 1 coefficient. And we're going to isolate that, so we're going to move the 4y over. So we've got x is equal to 4y minus 1. That's step 1. Step 2 is to plug what you just solved for into the equation you didn't use. So we didn't use 2x plus 2y in step 1. Now since I solved for x, I'm going to replace x. I'm going to substitute in 4y minus 1 in for x. So we've got 2 times 4y minus 1 plus 2y equals 3. So nothing else is going to change. We're just going to take out the x and put in the 4y minus 1. We're going to distribute, so we've got 8y minus 2 plus 2y. By doing that substitution step, we've gotten rid of the x and now we only have one variable. Once we have one variable, we can solve for y. We've got 10y minus 2 is equal to 3. Move your 2 over, we've got 10y is equal to 5. Be very careful when you divide here. We've got y is equal to 1/2, not 2. 5 over 10 is not 2, it's 1/2. And our last step, step 3, in our first step we had x was equal to 4y minus 1. Well, now we know what y is, so we plug the y in. So 4 times 1/2. Half of 4 is 2, 2 minus 1, we've got x is equal to 1. Therefore, our solution to our system is 1, 1/2. Just make sure that every time you solve for your system, your x-coordinate comes first because it's still representing that point of intersection on your graph. And when you have a point of intersection, your x-coordinate is first, your y-coordinate is second. Most likely what you used was elimination, or you prefer elimination over substitution. You can use either method you want. When we look at elimination, our goal is to get one of our variables to cancel out. So we need opposites. Opposites are same number, opposite sign. One's positive, one's negative. And I look, 2 minus 2 is 0. So our x's are canceling. We're going to combine 4 minus 2 to get 2y. 8 and 4 is 12. Now don't think about adding your equations or subtracting your equations. All you're doing is combining them. So if they're positive, you're adding. If they're negative, you're subtracting. But you're not always doing adding, you're not always doing subtracting. Then we divide by 2, and we've got y is equal to 6. And we know that once we have one variable, we can always solve for our second variable. You can go back to either one of those original equations. So I've got 2x plus 4y equals 8. And we know the y variable, so we plug in for y. So we've got 4 times 6. 2x plus 24 is equal to 8. Move that 24 over. We've got 2x is equal to a negative 16. Which means x is a negative 8. Put our two pieces together, and our intersection point, or our solution to our system, is a negative 8, 6. Alright, two more problems to review our substitution and elimination method. We're going to start with our substitution. Again, for substitution, it's a three-step process. We look, we've got a 5, a 1, a negative 10, and a 2. Step 1 is solving for the easiest variable, which in this case is y. We move the 5x over, so it becomes a negative 5x plus 12. Step 2, we're going to use the equation we did not use in step 1. And since we solved for y, we replace y. And we're going to replace y with the equivalent expression, which is a negative 5x plus 12. Remember, that sign means equals. So y has the same value as the whole expression, negative 5x plus 12. Alright, so we got a negative 10x minus 2. We replace y with a negative 5x plus 12 equals 4. Remember, everything else is going to stay the same. We just replace the y with our expression. You want to be very careful. Make sure that you distribute a negative 2 times a negative 5 to get a positive 10x. A negative 2 times 12 is a negative 24. Equals 4. We combine our like terms, a negative 10 and a positive 10. Well, those end up canceling. I've got a negative 24 equals 4. I look at that and realize I have a problem. I no longer have any variables. If I don't have any variables, I can't solve for anything. So I look to see what I'm left with. I've got a negative 24 equaling a positive 4. Well, that's not true. If your variables cancel out and you are left with an untrue statement, that means you have no solution. Which means if you put together what we did yesterday, when you have a no solution, that means that our two lines in our system must be parallel lines. So they may not look like it, but if I were to solve both of these equations for y, they would have the same slope, different y-intercepts. So we have a no solution when our variables cancel out and we have an untrue statement left. Alright, last problem. We're going to use elimination. So our goal is to get either our x's or our y's to cancel. When you're doing this, you're looking for the least common multiple. So if I want to eliminate my x's, I need the least common multiple, which is 4, and I would need a positive 4, and I would need a negative 4. If I had two positives, I would have 8. If I had two negatives, I would have negative 8. I want one positive, one negative, so it becomes 0. So I'm going to multiply the top row by a positive 2. Remember, you could have chosen to eliminate the y's, doesn't matter. 2 times 2 gives us 4x. 2 times a negative 3 is a negative 6y. 2 times 4 is a positive 8. Just make sure that when you are doing your elimination method, that you're distributing that number to all the pieces on the left and all the pieces on the right. We did not change the second equation, so let's recopy that down. We've got 4 minus 4, gone, 0. I look at my y's. I've got a negative 6 and a positive 6. Well, my y's have canceled out as well. So on the left-hand side, I've got 0. On the right-hand side, I've got 8 minus 8, which is 0 again. So I have the same kind of problem I did in number 3. I have all my variables canceling out. I don't have any x's left. I don't have any y's left. I look at my statement. I've got 0 equals 0. Well, that is a true statement. If you have a true statement when the variables canceled out, that means you have infinite solutions. And connecting this to what we did yesterday, if I have infinite solutions, that means that my two lines in my system, those must be the same exact lines. If I were to solve for y for both equations, I would have the same slope and I would have the same y-intercept, which means I would have two lines on top of each other. That's why everything ended up canceling out, and I had nothing left on the right and nothing left on the left, giving you infinite solutions. Alright, and that is for your review on your substitution and elimination method for solving systems of equations algebraically.